Hey everybody, hope you're doing well. This is another lecture from your teacher, Mr. Fleming. All right, so this week we're going to learn about horizontal asymptotes. So before we do that, I want to do a quick review of last week's stuff because all of this stuff compounds. So last week we learned about vertical asymptotes, or VA, and we also learned about holes that you can find in these rational function graphs. So remember, your first step for these is always to factor first and then to cancel if necessary. Because if you cancel out some stuff, you might get a hole. So we're going to do an example problem. So you have x squared minus 9 over x squared minus 3x minus 18. Okay, so we factor the top, factor the bottom. This one's going to be x plus 3, x minus 3, little difference of squares. And then this one is going to be, we have like x plus 3, x minus 6. So we've got 3 and 6 is 18. Okay, I noticed that the x plus 3's cancel out. So because we canceled that x plus 3 at the bottom, we know we're going to have a hole at x equals negative 3. And then our final form is going to be x minus 3 over x minus 6. Well, I look at the denominator, and when is x equal to 0 in the denominator? Well, that would be x equals 6 is the vertical asymptote. Okay, so great quick review. So the next quick review we want to do is about degrees and leading coefficient. So it all comes into play here. So remember, when you have a polynomial like this, x plus 4 plus 5x plus 2, you're going to have two. Let's look at the degree. So the degree here is going to be 4 because that's the highest exponent, right? And leading coefficient, well, that's just 1 because there's no number in front of this x. Say now we have, let's go to 5x to the 7th power plus 6x to the 6th plus 4x to the 5th. Okay, so our degree here is 7 because that's the highest exponent, and our leading coefficient is whatever the coefficient is of the biggest one, so that's going to be 5. All right, so that was a little quick review for everyone. So now we're going to get started. So when you have these rational functions, you're going to notice that sometimes they have horizontal asymptotes too. And it's going to depend on what's in the numerator and what's in the denominator, the degrees of those. Okay, so, yeah, horizontal asymptotes. Look at the degree of the numerator and denominator. Remember, if you need a quick review, you have n over d, right? Numerator is on the top of the fraction, denominator is at the bottom. All right, so if you have the degree of the numerator is greater than the degree of the denominator, you're going to have no horizontal asymptote. So for example, if you see something like x cubed over x squared, that's no horizontal asymptote. Okay, if you have n is less than d, your horizontal asymptote, or HA, is at y equals 0. Or that's just the x-axis. So like, you know, your asymptote's going to look right on that x-axis right there. If your numerator, the degree of the numerator equals the denominator, look at the leading coefficients. All right, so say for example, you have 5x squared plus 7 over 2x squared minus 8. So now you notice that these have the same degree. They both have a degree of 2. So the horizontal asymptote is going to be the 5 over the 2. Y equals 5 over 2. So just put the leading coefficient of the top in the bottom, and that's your horizontal asymptote. Pretty great. So we're gonna do just some quick examples and then send you on your way. All right. So the first example we have is, let's see, we have 8x plus 1 and then 4x squared minus 3x. All right, so I noticed that the degree of the top is 1 and the degree of the bottom is 2. Okay, so that means the numerator degree is less than the denominator, which means we have a horizontal asymptote at y equals 0. Okay, great. So for the next one, we're going to have 9x over 5x minus 2. All right, so I notice that the degree of this one is 1 and the degree of this one is 1. So you know that the numerator equals the denominator. Okay, so we know that a horizontal asymptote is going to be this 9 over the 5. 9 over 5, sorry, equals y. Okay, and then the last one we're going to have is x squared plus 3x minus 6 over 4x plus 5. All right, in this case, we know that the numerator degree is 2 and the denominator degree is just 1. Oy. So then we know that the numerator is greater than denominator, so we have no horizontal asymptote. All right, pretty good.